Hi, today we are going to be looking at a very quick introduction and rather a recap of linked lists. So let's get right into it. What exactly are linked lists? Linked list is actually a linear data structure. However, unlike arrays, linked list elements are actually not stored in a contiguous memory order. In fact, the elements are actually linked together using pointers. So here on the screen we have a simple structure of a linked list. So we have a head. So head is actually a pointer to the start of the linked list, and the linked list has 4 nodes as labeled by node 1, 2, 3 and 4. So each node, there's 2 different components within a node. Number 1 is the data, and number 2 a next pointer. So the data is actually the value that the node contains. So for example, this can be like a number or it can be a string, and next is actually a pointer to the next node. So in this way we can see that the head points to node 1 points to node 2 points to node 3, and 3 points to 4, and when we reach the end node of the linked list, the next pointer actually points to a null node, and in Python the null node is actually none. So that's the exact structure of a linked list. And here's a very quick and simple definition of a linked list in Python. So we can define a class called node, and the class of node has 2 different variables. Number 1 is the value, which is denoted by val, and number 2 is the next pointer that we actually saw in the previous slide. So the val variable actually contains the node's data, and the next variable actually points to the next node. So to give you a quick example, we have y and we have actually created a node with the value of 2. So when using this initializer, we can see that it takes on the value of 2, and because there is no next node that is given, this actually automatically points to a none node. So this is what is happening. And next we have x, where we are creating a node with a value of 1, and we are giving the next node that it points to as y. So this means that x will have a value of 1, and this node will actually point to y. So how does this look like? So here's how it looks like in this diagram here. We have node x with a value of 1, and we have the next variable which is a pointer to node y, which is here, and that we have initialized to a value of 2, but we have not given a next pointer for node y, so that will point to none. So this is a very simple linked list with just 2 nodes. Next up, let's take a look at some of the advantages of using a linked list. The first advantage is that linked lists have dynamic size. This means that we do not need to decide on a fixed size when we initialize the linked list. So this is in contrast to arrays, because in arrays what happens underneath is that we are actually working with a fixed initial size, and when we reach the capacity of this array, what happens is that we reallocate memory for an array of contiguous memory of double the size, and we have to copy all the elements over. So this is how it works. But with a linked list, all we need to do to add elements is to just add a new node, and we add a new pointer to that node. So in arrays, if we actually need to insert or remove any data, we actually need to shift the rest of the elements. So for example, if you're inserting an element in the middle of the array, that means we have to actually push all the elements at that point onwards to the right of the array. But in a linked list, all you're going to do is to actually add a node. We are going to remap this previous node to point to the new node, and the new node's next pointer to the remaining of the linked list. And this means that we actually get the ease of insertion and deletion of nodes with O1 time, which is constant time, versus On, which is linear time with arrays. And of course, linked list is also a recursive data structure, which means you can actually implement recursive algorithms with it, and that is going to be really helpful in some of the questions that we will be looking at soon. But there are also some drawbacks with linked lists. For example, random access is not allowed, and access is only done sequentially. So for example, if you're doing a search for a particular element, you have to actually go through the entire sequence of the linked list node by node to find this index or this element. And this means that we have a linear time complexity because of this linear search approach, and algorithms like binary search won't be applicable with a linked list. Also, Because each node has a pointer to the next node, we are allocating extra memory space for each node. The other drawback of using a linked list is because as compared to an arrays which have contiguous memory allocation, which means all the elements are allocated in contiguous order. Linked lists do not. So this means that arrays can have better cache locality, and whereas it's pretty hard to actually maintain cache locality for linked lists because all the pointers to the various nodes may be located at different parts of the memory, and this can actually make a big difference in performance depending on the context. And of course, if you would like to learn more, do visit rightfrombasics.com, where you can see a quick introduction to linked lists based on Python. So that's it for this video. I hope this was really helpful for you, and I'll catch you guys in the next video.